Hello, my name is Russ Teubner. I'm the CEO and co-founder of HostBridge Technology. Today, I'd like to take a few minutes to talk about using CICS Services as part of your API and business services strategy. What I'd like to do in this presentation is go back, let's say about 17 years and kind of walk through the progression of what we've seen within our customer base, within the mainframe industry, and the way integration has been approached. And I'm going to start back in 2000 because that was really the beginning of the HostBridge journey for Scott Glenn and myself as the founders of HostBridge. We decided on the basis of some conversations with various customers at that time that it was simply time to eliminate screen scraping as an integration technique or approach, as we say, from the face of the earth. Fortunately, IBM agreed with that perspective, and in about 1999, 2000 timeframe, they introduced some fundamental technology in CICS that made that plausible. It didn't work out of the box necessarily to accomplish that goal, but it definitely laid the foundation. And that component within CICS, which began back in CICS Transaction Server version 1, was called the Link 3270 Bridge Interface. And using that particular interface, we were able to create a software product that allowed a distributed app to send in to HostBridge running under CICS, an HTTP request, and receive back a document, an XML document, or today it could be a JSON document that had all the information from that terminal-oriented transaction. Now the magic was we were able to interact with that terminal-oriented transaction with absolutely no screen scraping. In other words, we were able to send data to that transaction and receive data from that transaction without making any references whatsoever to rows and columns. And really that's the essence of screen scraping as an integration technique. When you're creating a binding relationship between something outside the mainframe and an application running under CICS on the basis of rows and columns. That, of course, as we now know, 17 years later, or looking back, we know that that was a poor integration technique simply because it made the integration very brittle. If someone with great intentions came along and changed that terminal-oriented application and moved something around on the screen, the integration could break. So the critical thing was making sure that we could accomplish that integration without screen scraping. And that's really where the HostBridge journey began. And so we say that integration in general and HostBridge in specific, right around 2000 was represented by this picture. We were now able to communicate from the outside world into CICS to a terminal-oriented transaction with no screen scraping. But remember, there was one request coming in from the distributed app and one response going out. It was, as we sort of say, a one-to-one world. By 2002, customers wanted a bit more. It was still a one-to-one world, one request in, one response out, but they didn't just want to run a terminal-oriented transaction. They wanted to also run a COM area program. And so we added that as a feature. Not an earth-shattering feature to add, certainly. There are many ways that you can execute COM area programs, but having one platform like HostBridge that could do both was tremendously valuable to a lot of our customers. Around 2004, we saw our customers using our product to add value to their organizations. And a lot of them were beginning to enhance their distributed applications to make not just one call into HostBridge, but to make multiple calls. And sometimes they would make multiple calls to fulfill one business service. So for example, imagine a financial institution that wants to provide you as their customer with a synopsis of all of your accounts on your mobile device or on a browser-based screen. Perhaps that distributed application might send one request in to be able to get your checking account balance and get a response, and then send another request in to get your savings account balance and then get a response, and then maybe a third one going in to get a credit card balance and then receive a response. So customers began to build their applications where the distributed applications were sending in multiple requests into HostBridge. We would do our thing, starting a terminal-oriented transaction or interacting with a COM area program and returning the response. But we began to look at that at some of our customers and begin to have concerns. And very specifically, we said, that's really a bad idea. And that is, if you know you're going to be always sending these three requests in this sequence, that seems to be a terribly inefficient way to go about that business. Not only do you incur the added latency of sending multiple requests and responses from the outside world into the mainframe, but it also ends up consuming more mainframe CPU cycles because there are simply more requests that have to be handled across that boundary coming into CICS and then going to the outside world. Okay, so we said it was a bad idea, but the question was, how do we solve that problem? We decided what they really needed was an engine, and we'll just call it that, just something running under CICS that performed the automation according to their specifications. So there would be one request coming in, some bit of automation would occur. We would then, in that automation, interact with terminal-oriented transactions, comm area programs, or directly with the data. But what? How would we do that? Well, again, this was 2004, and we did a fair amount of research at that time, and we decided that JavaScript was destined to become not only the world's most popular programming language, which it is right now, but it was also a great language for automation and integration. Clearly, we thought it would grow in prominence, and 13 years later, we're happy that our confidence in JavaScript has been well rewarded. And so what we did back in 2004 was we implemented the very first server-side JavaScript engine running on an IBM mainframe and under CICS. And that allowed a customer to be able to author a bit of JavaScript, which is very concise, and be able to then orchestrate all the activities on the interior side of CICS. What that meant was one request could come in, the JavaScript program would run, it would do the orchestration, and one response would be returned. Now, in choosing to use JavaScript as the method for integration on the mainframe, we made a number of choices, very conscious choices. Specifically, we decided not to use a modeling or a diagramming approach. And we did that for a very good reason. Now, first of all, there's nothing wrong with modeling or diagramming. And by that, we mean using some sort of a tool that lets you create a flowchart or a Visio-like diagram that says, if this, then this, and kind of continues on. But we decided that that was really inappropriate for what we would call microservice or microflow automation, because at some point the diagrams just become too big. There are too many details to attend to. So we think that modeling and diagramming, we thought it was a perfect approach for kind of a higher level of abstraction. Let's say if you're orchestrating the activities of an IBM mainframe in conjunction with a whole different computer system. So where you're orchestrating activities across 2, 3, or 4 discrete systems. But when it came time to actually orchestrate the transactions, the program, and the data elements on the mainframe running under CICS, things that occur in microseconds or milliseconds at most, that using modeling as a way to describe how those events and activities should be orchestrated was just inappropriate. You just couldn't create enough flexibility in the modeling or diagramming tool to account for all the possibilities that could occur with applications that were written 10, 20, 40 years ago. So, as I said, that choice was really based upon our own experience, but also from input from customers. They had terminal-oriented transactions that were complex. Their programs had complex comm area layouts. They wanted to build services that relied on transactions in complex ways. So obviously the key word there is complexity. So we fast forward to 2017. JavaScript is in fact now the most popular programming language on the planet. And we're really happy, satisfied that our customers have people writing services for CICS who have never even seen a mainframe. It also doesn't hurt that we live in the age where coding is now cool and fun again, and JavaScript is certainly at the forefront of that movement. So here we are back in 2005. HostBridge became one of the world's first implementations of server-side JavaScript and the first on the IBM mainframe. And you can see it exemplified here. So the JavaScript engine is running on the mainframe inside of CICS doing all this orchestration work. Now, another thing that customers said to us a number of years later, perhaps I think it was around 2010, right about then IBM came out with the concept of specialty engines, particularly ZAPs and ZIPs. And our customers said, we love what you're doing and we'd like it all to run on a ZIP. Well, again, thanks to IBM, who created a licensing program that allows an authorized ISV or software developer such as HostBridge to be able to use the appropriate interfaces, we were able to accommodate our customers. So for the last 7 years, our customers have been able to benefit from running all of their integration tooling and technology and all the scripts that they write using the HostBridge JavaScript engine on the ZIP. Okay, so now let's fast forward to the present day. One of the things that's really important in organizations is formalizing the API boundaries. This is now a priority for organizations. IBM has recognized this, as have many other vendors, and they're creating various types of API management solutions. A good example of that is ZOS Connect, which provides a very disciplined way for being able to interconnect from the outside world into the mainframe world. We see ZOS Connect as another alternative to be able to get a request into CICS, no differently than any of the other conduits or channels that we've supported over time. So we show ZOS positioned here as something that would act as an API management layer in front of HostBridge. So on this diagram, I want to make one very clear point, and that is that while HostBridge can support ZOS Connect as a means of invoking a HostBridge service, it's very important to realize that ZOS Connect does not do what HostBridge does. What ZOS Connect does is allow an application on the outside world, that distributed app on the left, to be able to send in a request, and ZOS Connect could directly invoke a comm area program on a one-to-one basis, as we used to do about a decade ago. But what HostBridge does, as you now know, is very different. We are an automation engine. So that request that comes in, whether it's directly through HTTP or via ZOS Connect, it will come into the HostBridge engine, and the script will be invoked, and we will orchestrate the activities of multiple program or data elements running under CICS. So again, it's very important to realize that ZOS Connect does not do what HostBridge does, nor do we do what they do. They're very complementary and distinct technologies. So let's talk about what customers need now. Now that we've already created this automation and orchestration engine that is zip enabled, where the automation technology is authored in JavaScript, and we're able to orchestrate activities on the inside of CICS at millisecond or microsecond speeds. What do they need now? Well, what we're hearing is they want us to be able to expose all of that CICS-based activity to platforms like Splunk. Now, Splunk is perhaps one of the most well-known examples of technology that falls into a category that many people call the SIEM marketplace, or the Security Information and Event Management Marketplace. And these platforms have the ability to take data from all sorts of disparate systems and correlate that activity for better management, better control, better auditing, or for various types of machine learning activities, understanding how their network and all of its application components work. So one of the things that we've focused on is making sure that we can expose CICS-based activity to platforms like Splunk. To do this, we have chosen to leverage a feature of IBM's CICS called transaction tracking. And using this as a foundation, we can now layer on top of that lots of very rich information. And particularly not just add value to transaction tracking, but really connect the value of transaction tracking running under CICS with the outside world. What we're illustrating here is that there is now a component that can be installed under CICS that we are currently calling the HostBridge Transaction Analytics Connector. And what that HostBridge code does is augment transaction tracking by allowing correlation data received from the outside world, and it might be received via an HTTP header or via a CTG COM area or a container. We're allowing that correlation data to be externalized to platforms like Splunk. One of the questions we're asked is, will this work with just HostBridge or with any CICS activity? And I'm pleased to tell you that the approach that we've taken in our design will work with any HTTP-based workload, not just with HostBridge, or with any workload that is driven via CICS Transaction Gateway. So, thank you very much for taking this brief history of time with me from 2000 to 2017. I hope we've been able to organize some of the information about some of the megatrends that have happened in the integration space, particularly with respect to CICS over the last 17 years, and more specifically highlighted how HostBridge has been very progressive and has been at the forefront of each of those steps in the evolution of integration to CICS and the mainframe in general. If you'd like to learn more, please go to our website or send us an email or even give us a call. Thank you very much.